Hello, this is Tiffany Harris from AWS Educate. Thank you so much for joining the Supporting Rapid Transition to Remote Learning webinar series from Amazon Web Services. Educators around the world are rapidly transitioning to remote learning, some for the first time, and we wanted to do something to help ease the transition. This webinar series was created for educators by educators who have expertise in remote learning and can share their insights with you. The series runs through May 1st, so check back on the website each Monday to view new webinar topics. You're going to be muted during the webinar, but we want to hear from you, so please put your questions into the questions pane of the GoToWebinar control panel. We will answer questions throughout the presentation, and we also set aside time at the end of the webinar to answer questions. Note that this webinar is being recorded, and you will receive a link to the recording one day after the webinar. You will also receive a certificate for attending the webinar. And with that, I'd like to introduce Dr. Schanke from Harrisburg Area Community College in central Pennsylvania. Dr. Schanke is going to discuss labs in the cloud, moving classroom labs online. Take it away, Dr. Schanke.
Thank you, Tiffany. My name is Robert Schanke. I'm a professor, as Tiffany said, at Harrisburg Area Community College. I've been here, this is my 5th year teaching, and before this, I worked in industry for about 20 years, where I worked with a lot of new technologies, including virtualization. And those of us in industry have been working with virtualization for many years, but in higher ed, it seems to be a relatively new technology. And what I've done over the past 4 years is worked on taking my classroom labs and moving them into an online experience so students could take what was previously only teachable in the lab due to the equipment and servers and make an experience where they could do that remotely. So in today's presentation, I'm going to talk a little bit about what the cloud is, why we need it, and then cover how I've transitioned some of my classroom labs into the virtual environment. So why do I need the cloud? What is it and what can it do for me? Cloud itself is a very general term that encompasses many different areas, but what I'm going to specifically talk about is the infrastructure as a service. With infrastructure as a service, we can actually take advantage of the ability to virtualize. In other words, take a server or a PC and create an image of that lives in the cloud that we can access remotely. So when working with servers in the clouds, we have a lot of advantages, and one of them is the ability to quickly deploy and configure machines that fit our needs. So we can dynamically create these computers, servers, even entire networks in a secure environment that can be accessed from almost anywhere. You only need an internet connection, a web browser, some remote desktop connection software, and most of this is widely available. There are some pros and some cons to this. Let's first talk about the computer lab that you traditionally see. So often in our educational settings, courses have specific hardware or operating system requirements, and many of these are expensive or almost impossible for students to install on their own computers. As a result, students in these courses typically spend a portion of their week going to a lab, using the computers with the pre-installed software, and being forced to sit in a classroom at a particular time. Now, this works great a lot of times, but students take sick days, they use vacation time, schools close due to inclement weather or natural disaster, or what we're facing today. There's just times when students cannot get to these labs to use the software. In addition, many students also prefer the flexibility of online and blended courses. So they provide students the ability to work at any location rather than losing time having to go to a lab. And this ability to work remotely is a benefit, because without it, students that take vacation, that are sick, or that for whatever reason cannot go to the lab, it can be very detrimental to the students' ability to meet the learning outcomes of the course. So what sort of specialized software or hardware am I talking about? Well, think about it. What about Microsoft Office or Windows and Mac operating systems. Microsoft Access only works on a Windows computer and not Mac computers. So if a student has taken a course such as word processing and using the Microsoft Office package, they can only support that on a Windows computer in a Windows computer lab. And students are only able to do this at home if they have a Windows computer. Students with a Mac computer are left out because Microsoft Access is not supported on the Mac. Well, it goes beyond that. Think about more advanced topics such as game program, 3D modeling, even CAD, CAM software. Any of these software that require an advanced server concepts, internetworking, cybersecurity, anything from the basic Office 365 up to cybersecurity require some sort of specialized lab environment for students to work in. However, as I previously mentioned, a lot of students don't have the ability to run these complex environments at home. And on top of that, many institutions only have a handful of specialized computer labs available. At our university, we only have one lab on each campus that can support internetworking courses. We only have one lab on each campus that can support servers. So computer labs aren't always available. When you're teaching a class in one of these, students who might want some help that are in a different section, maybe they can't use that lab, maybe it's shared. So those students are losing out on the learning activities. They're no longer able to go to the lab when they need to. There's set times. So what happens when students need to access the computer labs, but they can't? How do students continue to learn and work on these skills? And I have found that the cloud and the power of virtualization allow you to provide students access to these software and lab environments almost anywhere and almost any time. I think it's becoming more common that students have the technology and the internet connectivity to work remotely. So today's students, they're more prepared than ever to use the internet. Many grew up using technology and, more importantly, using the internet. These so-called digital natives, they're accustomed to using apps to communicate and create and to learn. And according to the National Center for Education Statistics, in 2017, over 97% of students ages 3 through 18 had access to some form of computer or smartphone at home. So while a laptop or desktop computer may still be the most common form of technology used by students at home, there's little doubt that the strong majority do not have the technology resources to replicate some of these more complex labs. So many students may have an appropriate computer to run word processing software, but what about the 3D drafting or configuring an authentication server in a client server environment? These just simply cannot be done with the technology that most students are going to have at home. So technology exists where we can replicate many of our complex computer labs in a cloud environment. And many students already have the technology at home needed to access these online labs. This brings me to labs in the cloud. So we're going to talk a little bit about how we can, leverage this cloud environment to replicate our classroom labs and put them into a space where students can access remotely. So suppose you're teaching a course on a desktop spreadsheet software. So a simple application that doesn't require a powerful computer. In a lab setting, you can control almost all aspects of the computer in the lab environment. Each student will have the same computer operating system, the same version of the software, the same amount of hard drive space, etc. They are all identical. If a student has a problem, it's generally very easy to troubleshoot because all the computers and all the software are the same in your lab. But what if that student goes home to continue working on the assignment? Most of the time, there might not be a problem, but what if? What if the student is using a different operating system at home and there's subtle differences in how the software works? Think about a Mac computer versus a Windows. What if the student has not applied the most recent updates to the software? What if the student did not install all the features required? What if the student is using a tablet or a Chromebook and it can't even run that spreadsheet software at home? Well, one answer could be assign each student a school-owned laptop to take home and work with. This could work well, but it can also be costly to purchase, difficult to maintain, and still require some intervention to ensure that all devices are configured and patched appropriately. So what about the virtual lab? Right? A better solution might be to virtualize the lab. There are many ways to do this, such as the AWS Classroom, AppStream, EC2 instances. Using these technologies, you can guarantee that any student with a Chromebook, Mac, PC, and an internet connection can access the same lab almost anywhere and almost any time. So we talked about some simple software, but what about more complex labs? The cloud can provide complex lab environments for many things, drawing and drafting courses, 3D modeling, game development, server database administration courses, networking, cybersecurity, and many more. Virtually any complex lab environment could be replicated in the cloud, and this would allow students to have access to their complex lab at a home environment using their device and their technology. We'll talk about one of the courses that I have recently converted from a classroom lab to a virtual lab, and that is my game design and development course. One of the courses that I have problems with was getting Unity and having students access Unity at home. In the classroom lab, I'm able to ensure that students have the proper operating system, they have enough memory, the servers are configured, we have the right video cards, and everything is set as I need. Generally, I have one or two students that have a powerful desktop or laptop at home, and they come and they have asked me, Professor Schanke, can I install Unity on my home computer? And I say, sure, but with Unity, we have version issues, we have sharing of assets, and not only that, it's a lot more work for me to have to troubleshoot an installation on 5 different types of computers at 5 different students' homes 24/7. It seems like as a professor supporting remote technology, it's a 24/7 process. We get emails and calls all the time. So with Unity, it's not that taxing. It doesn't require a lot. It just requires a modern processor. It's not too difficult. The licensing isn't too bad, but the problem really becomes the standardization. So when I was able to virtualize the Unity game environment, I was able to create a cloud classroom using Amazon AWS Educate, and I was able to then give credits through this cloud platform to my students. The students use those credits, and they created an EC2 instance, which is the virtual server environment in the Amazon cloud platform. Within those EC2 instances, students were able to install the Unity platform. Now, whether they were in the classroom or they were at home, students would remotely connect to the same environment and have the same Unity instance both places. So this provided an equal playing field for all of my students. They were able to work on their assignments from nearly any location and from nearly any time. Students were also given the additional benefits of being able to create and host their game servers and host web games on the internet throughout the EC2 and the AWS cloud platform. Another course that I've recently updated to host in the cloud is my Database Administration 2 course. So in this course, I teach students how to install and configure relational database management systems, as well as configure security and connectivity between the servers and clients. So the technical requirements of this lab were fairly complex, and our local IT was able to provide a partial solution, but to do a complete solution would have been a major expense and would require us to dedicate almost an entire lab room just for the single course. And what we had settled in the classroom was a single database server accessible from a local network in this classroom, and then all computers shared the local network to that database server. So this worked okay, but it didn't give me the exact experience that I was looking for. When I was able to virtualize this and move the lab into the cloud, I again went back to the EC2 instances, and I had each student create their cloud platform, install the client and the server software on multiple EC2 instances. And this way, they had their own encapsulated network that was free from interfering with the campus network. It was isolated to only their cloud platform that they're working in, and they were able to set up multiple clients and the database server and fully configure the network, the firewall, the security rules. So not only did I get the benefit of a better environment that students could work at in the classroom or remotely if they were doing homework at home, but they also had a step up in the fact that they're working with real world solutions and not in a lab that's predefined. So in other words, not only did they have to create these servers, they got the experience of configuring the network. They got the experience of setting up the security settings. And they were able to make a fully functioning client server database experience using real technology, not simulations and not sharing resources. And it was, I think, a heightened, elevated experience, learning experience. And this not only, gave them more confidence, but also it definitely, I think, made them more prepared when they entered the workforce. So the cloud can be used for much more. It's not just CIS that I've talked about, but there are many different disciplines that can benefit from this. Some of the other classes where I've helped other faculty successfully implement AWS education and the EC2 instances include courses on installing and managing Microsoft Windows operating systems. I've helped instructors work with SolidWorks CAD modeling, AutoCAD drafting software, and we even experimented with the Esri GIS mapping. So in each of these cases, there was a need that was identified where some or all the students did not have the ability to run the software on their personal technology, yet through the power of virtualization and using the cloud, they were able to access the software and have the exact same lab experience remotely as they would if they were sitting in the classroom. So the cloud, it's a versatile platform. It allows you to replicate and at times improve on the classroom labs. Especially when you rely on specific software, hardware, or network configurations that make it difficult or reduce the number of labs that are available, so students have to schedule time or can only go during certain times. In higher education, I see a lot of non-traditional students who perhaps are working throughout the day but would love to come into the labs in the evenings. And when you have specialized labs, we don't always have staffing to keep them open when students need them. But through virtualization, it's a no-brainer. Students are able to access my labs 24/7 as long as they have some sort of device that can support the remote desktop and they have some form of internet connection that can support it. So in conclusion, I just want to talk a little bit about some of the benefits of a virtualized lab environment for both the classroom and remote education. So again, not only are virtualization and the cloud an excellent solution for providing standard desktop and software configuration to students at home, but it could also simplify the classroom experience and the lab resources by reducing the need for specialized lab spaces. Using existing technologies in the classroom, teachers and students could quickly change from one desktop and software configuration to another. Through this power of virtualization, and the cloud, Chromebooks, Macs, PCs become the means to access the lab rather than the lab itself. Not only can this simplify and reduce complex lab configurations in the classroom, it also provides the benefit of allowing students to start working on the lab in the classroom and then pick up where they left off at home or even while they're on vacation. Students will have remote access to the same labs that they do in the classroom, and they will be able to access these labs from anywhere. Student who misses class will no longer miss out on the hands-on experience. Virtualization, could potentially result in cost savings to educational institutions as well. It can reduce the number of labs that require specialized hardware and software and licensing. It can reduce the cost to build and maintain the labs. It will also potentially reduce the time needed by your IT department to support and maintain all these labs and equipment. This will free them up to focus on other resources and other projects. So I feel that virtualization has the potential to help educators contribute to student success, retention, and satisfaction. The standardization of labs eliminates the need to support each piece of hardware and software configuration that a student might have, and it also potentially reduces the likelihood of technical problems while reducing the need for technical support. And as any of you that teach in these complex labs know, technical support, it's not only a source of frustration for the students, but it's also a barrier to them achieving the course outcomes. So how do you get started? There are a lot of great and free resources out there. So I linked to a couple on here. One is Amazon's YouTube channel, which has a lot of excellent resources, and the other is my personal YouTube channel, where I just have a couple snippets of videos that I have out there that are public to demonstrate the types of material that I created for my students and other educators that I have trained on. And you'll see maybe 15, 20 minutes worth of videos is all it takes to get students from I don't know anything about the cloud to running their own virtual servers in the cloud. And of course, we always have the Amazon AWS Educate website. Go there, and that's where you can find out all the information about the technologies that I've been using in my classrooms.
Thank you so much, Dr. Schanke, for sharing your expertise with us. And thank you, everyone, for your active participation through the questions pane. We really appreciate all the questions and comments so far. As I mentioned earlier, we're going to be hosting more webinars on remote learning, and we're also hosting office hours to answer any further questions you might have. You can find information for both the webinar series and the office hours on our webpage found on the screen and in the chat. Also, a link to the recording of this webinar and a certificate of completion will be sent to you via email within 24 hours. Lastly, you will see a survey pop up when you close the webinar. Please provide your feedback on the survey so that we can continue to improve these webinars. Now we'll continue to answer questions through the questions pane of the GoToWebinar control panel until the top of the hour. Thanks, everyone.
Thank you, Tiffany, and thank you, Dr. Schanke. Hello, everyone. This is Grant Irons, also with AWS Educate. I actually have a couple of questions that I would like to ask. First of all, whenever you create these labs for students, how do you communicate with the students?
So generally, a lot of my classes traditionally are already on an online format, but I also teach some of these more complex ones, in person. And recently here in our area, and I think a lot of areas, we've had to go to remote learning. So it's communications is key. So it's an email is my primary means of communications, and we also use our course management software, which has some areas for discussions and news postings. But I am a big fan of the videos. I linked to a few of them at the end of my slideshow. If you get a chance to view, those are just a couple I made public. I have hundreds and hundreds of private and unlisted videos that I keep to tell students, what's going on, explain how the lab works, overview, walkthroughs, tutorials, all sorts of things to try and give the student that's working remotely a similar experience that they have in the classroom. So as we know, in the classroom, I can pull up the projector and I can walk around the classroom and see what they're seeing at the same time. Remotely, it's a little more difficult. So I have found oftentimes by walking through my classroom lecture in a video format, and I can zoom, from my face on the webcam to the screen, and they can see what I'm seeing as well as a person, because no one likes to see just a talking head on the screen, and B, people also want to see that you're there. So that back and forth between me talking, presenting, and what I'm seeing on the screen helps out a lot. Takes care of about, I found 90% of the questions and difficulties with the labs. The remaining, we just do some form of online collaboration. I'll either do like a group Q&A meeting at a set time or individual. Hopefully that answered your question.
Yes, thank you very much. It sounds like it's kind of a dance and figuring out what is the best for students based on the content that you're sharing.
Absolutely, and just to expand on that, it's also not just the content, it's also the student population. In higher education, we have all sorts. We have some, I would say the younger generation that grew up with computers that are very comfortable, and then some that maybe need a little more encouragement, because it's not difficult. And I have not, knock on wood, to date, I've never had a student not be able to complete or use an online lab. Sometimes it's just a little more help and encouragement getting started, but once they're in, they've found it very easy.
Good deal. And it sounds like you provide a lot of resources for them to help them. That's fantastic.
I think the communications is key.
Yeah. So we have a question from Florin. Interesting question. How do you replicate high-end video cards or sound cards necessary for CGI and audio workstations?
So that's difficult. There are there are different ways and tools that are provided. I tend to stick with mostly the free resources, just for cost standpoint, so I don't have to push that off to students. Generally, the lower end 2D modeling and some basic 3D modeling, your standard EC2 instance that you can get with the Amazon Educate credits, do a decent job. Some of the feedback I've had from other professors is it's like working on an older workstation. So it's functional, but it's not going to be real-time graphics. There are options. I know Amazon, the classrooms, they do have the ability to purchase higher end machines that specifically have the video card support and the higher end that you're looking for on that. So there are different ways of doing that. It's just you got to balance. A lot of times it's a cost versus an actual need. A lot of times where I'm working with the students, we're just now starting out and learning. It's okay for it to be a little bit slower, but there definitely are options, and there are upgrade options to get those higher end video cards.
Awesome, thanks. And you talked about cost, and that was actually another question.
Yeah.
For the labs that you have your students work on and some of the more complex labs that you mentioned, is there a cost, and who pays for it?
So far, again, knock on wood, I make use of the Amazon AWS Educate and the grants that they provide to me and my students. They're currently, I know it can change. I don't want to speak for Amazon in the future, but as of right now, when I sign up and create a class as an instructor, and my students each get a set amount of credits. When we set up our EC2 instances, every time you have that server instance running, you're going to pay a very small, either pennies or fractions of pennies per hour use, and then you got to add up if you have extra memory or extra hard drive spaces, any other advanced features. But what I found, maybe $1 to $2 worth of the credits are used for a lab session. It depends. Sometimes it's more, but as long as you train the students, but inform the students that these are live machines. It is live costing, but it's free coming out of the credits. As long as they shut down their labs when they're done with it, I found I get about 6 to 7 weeks in a given lab. So I usually work my labs around my class period. So mine are semester long, which is 14 weeks for us. So we do the introduction, we do the theory, then we talk about the labs. Then once we get into the labs, students have enough time with those free credits to complete the labs. Again, knock on wood, it's just a matter of understanding what and the number of components that you're using from the Amazon Cloud Services, because everything has a per hour cost, and as long as you build your labs around that, you should be fine.
Thank you for that. And this is a great opportunity to talk a little bit more about AWS Educate. I've put a couple of links in chat. One is just awseducate.com, and above that is what that translates into. But we encourage everyone to apply for AWS Educate if you haven't already, because you get many of the resources that Dr. Schanke spoke about. Free access to the AWS console, whether it's students and educators get your own what we call Educate Starter account, which is access to not all, but most of the resources in AWS, as well as the classrooms that he was mentioning, which are classroom environments that it's free access on top of the Educate Starter account. So the goal is to give students and educators access to AWS for real world application and usage, so that whenever they go and get a job, students go get a job, they know what the console is like, and they know how to use AWS and how to use the cloud. So again, would really encourage everyone to go to awseducate.com and apply if you haven't already. There were some questions about, one question, and you kind of already addressed this, but will EC2 work for GPU and CPU intensive applications such as computer graphics and frame rendering? The answer to that is yes. There are EC2 instances that have GPU that you can use through AWS Educate.
If it's okay, I just wanted to kind of follow up on something you said where you mentioned the real world application, and that's one of the other huge benefits that I found. We offer a course on virtualization as part of our program. It's an elective, but I found that many students get a majority of what they would learn in that other course through using these classrooms in the AWS cloud, because they are working with the types of interfaces, and they're real servers. They're real. It's not a simulation. This is something that they will not definitely, but most likely encounter when they leave the education and go into the workforce. So this is a really great way to learn real world equipment, not just lab computers.
Really good point. Thanks for calling that out. So talking about real world and complex labs, can you talk a little bit more about some other labs that you've had experience with, or where you've shared information with other educators? You talked about 3D labs.
Yeah, I can go ahead and talk about some of them.
Thank you, and I can't find it right now. Go ahead.
It's all right. Now, there's quite a few, and we're learning more as we go about this. So every time we have a successful semester with, it started out with me running, by my own for my courses, and then we moved on. It was funny, the GIS, geospatial class was the next one, and that really came out of a need for one student that had a need. Particular student had a Mac-based computer and was actually having to travel out of state for a while. So labs were out of the question. So that was our first experiment with a non-CIS course, and it worked really well. But from there, it's expanded to the next course that we are currently developing and building. Our labs, we build them in advance before we give them to our students as a walkthrough. But we have a course on Microsoft Windows foundations for using and installing and configuring Microsoft Windows, and we're currently experimenting right now with setting up the AWS labs so students can come in, get some experience with the initial configuration, setting up TCP/IP, DNS, and just basic communications. And these are students that are first year and no guarantee that they've ever used a computer before, to have that hands-on remote experience of working just with the operating system itself. And I thought that was really interesting because this was one of the courses where the instructors had a difficult time figuring out how they would teach operating system fundamentals to a remote student, because what they were thinking was the students are going to be on their computer. I can't have them going into the registry and making changes, formatting hard drives, or they're going to mess up their computer. And they also did not want the headache of supporting, 50, 60 different home computers every semester. And that's where the AWS Classroom came into play. It was a perfect opportunity to present students with a machine that they could mess up all they want to mess up, because it's not going to interfere with the lab. So our IT technicians on campus did not have to worry about students bringing up a DHCP server and taking down the rest of the LAN, or doing something they shouldn't be doing and messing up the computers. So students have a full admin access to these operating systems to do with, as they please, with little worry of messing something up on campus or on their home computer. So that was another exciting thing. And I think by far the most complex one that I've built, only because I've ran it a few times, is the database administration 2 at this point, because that's the one where we're spinning up multiple EC2 instances and really emulating a multi-server network in the cloud, and students get that hands-on experience from all levels. So someone that graduates from our program that's gone through this course, not only do they understand the theory about it, but they've spun up new servers, they configured the network, they've troubleshooted all the security, both internal network and the remote access, to be able to get to it. And taking that back, there was a question earlier about connecting to the virtual labs. I do not have, the question was about LDAP versus AD connections and network isolation, all that. When you set up these AWS Educate classrooms, the way I have it set up, that's an email invite. So students use their email, they set up their account with their passwords through the AWS Educate. So it is not tied in. At the moment, I don't have it tied into our Active Directory at all. So students have their own accounts. And when they spin up their networks, each network that they get is isolated to them. So they have their own private network. So that kind of goes back to the isolation, where whatever they spin up, whatever servers, whatever settings they do, is not going to interfere with anyone else.
Good point. Thanks for bringing that up. And I will dive a little bit deeper into that with regards to student accounts. So with AWS Educate, whenever students join, like Dr. Schanke said, they get their own account, and it's a temporary AWS account that lasts as long as they're a student. And then the classrooms feature that he was talking about earlier, that is another temporary account that lasts as long as the class lasts. So we're able to give students temporary isolated accounts that are their own, that they can, I love how you talked about, they can mess it up and don't have to worry about affecting their own system or the school network. So great use case for AWS and AWS Educate. You mentioned earlier that you always test out the labs before you assign them to students. Whenever you assign a lab to students, is there code that you maybe put in GitHub that they pull, or do they start from scratch and build all the way through?
So both. The answer is both. For my technical 200 level, the more advanced courses, I have them build from scratch. I think it's really important that students have the hands-on and the experience of, I would say, the frustrations is the learning. And if I hand them a completely configured machine, they're not learning as much as if they had to start from scratch. But again, that depends upon the course. For the game design and development course, there we have a lot of programming, so we use GitHub with that to share the source code, and that way we can all be working and sharing the same source code as a group. With that course, that one was kind of thrown into the mix. We intended on offering that fully remote in the fall. We had just started working on it when the current events happened and we had to cancel our classroom. So that we're kind of rushed into that, but the intent there that we are going to be running that starting in the fall will be the GitHub share. So students have a common workspace and shared source code. But again, it really depends. The entry level, the students that are non-CIS students, you can give them a configured instance and get it set up as much as possible so they don't have to go through all the installations if that's not one of the course outcomes, versus the more technical ones where an outcome of the course is to do the installation. The installation, in my opinion, starts with launch new instance of an EC2.
Makes perfect sense. So let's talk a little bit about the outcome of the course. How do you grade or assess students in a remote setting?
So there's a lot of different ways, and the one that I have found the most effective is to have students create videos and walk through the lab. So I provide a 1 to 10 page, it really depends the size of the lab, worksheet that has step-by-step the different keys that I'm going to be assessing, the different outcomes. And then usually a video companion that goes along with that where I kind of highlight, obviously I don't tell them how to do it, but I highlight or show something very similar so they understand where they're going and what they're doing. And then the students will complete that and either record while they're doing the steps, if it's an interactive process, or at the completion of the lab, they go back and highlight and with the video show A, B, C, D, this is what I did here, this is what I did there. I found that's the best. Although I don't like to admit it, I think most educators are faced with a small portion of students that do plagiarize work. I like many educators, there are certain websites you go to and find the answers to all your homework. So I always shy away from the screenshots because I found that screenshots are very easy to duplicate. So I ask for the videos now so I hear their voice. And I know it's unique. It's a lot easier for me to recognize the same video than it is the same screenshots. So that's one way of assessing. And the other way with the classrooms, one of the really excellent features there is, as an instructor, I have the ability to go in and look at the student's workspace. So if a student's having problems, or I just want to spot check, I can launch their workspace and it says, in essence, emulate that student and see every server, every setting, and either if I'm on a phone call or a web call with a student, I can be looking and actually helping them fix their problems, just as if I were the student. So that gives you kind of a second level. If you do accept the screenshots, because of whatever technical limitations, you could still go in as the instructor and pull up the students' labs and verify that they really did do them or not.
Thank you so much for talking about the ability to go in to students and view students' infrastructure, which is a part of the AWS Educate Classrooms feature. So really powerful way to assess. Love the concept of having them do videos. It's a great idea.
Question just popped up about some remote experiences, Experience Remote Lab. The AWS Educate portal, when you sign up, there are some free labs there that you can go to.
When you log into the portal, along the top there are tabs, and the leftmost tab is the content tab. And we actually have some full courses that are available to you. You can use the entire course, download it and upload it into your learning management system, or you can use some labs that are a part of those courses. We also have some independent labs that you can use. So on the AWS Educate portal, under the content section, there's some examples of remote labs specific to AWS. And Rob was talking about general labs and how you can use AWS for other labs, but the ones on our portal are specific to AWS. Thank you everyone for your time.